Hello and welcome back to Python, now with a bigger topic, which is multithreading. And yeah, as a German, this word is hard to pronounce. Multithreading. I hope I got it. Write in the comments if I pronounce it right or not. But let's not invest much into my pronunciation and let's get right to the topic. Multi-threading. How can you imagine multi-threading? What are multiple threads? You can, another thread you can imagine like a second path, like an execution path, but unlike two processes, multi-threading, multiple threads share the same memory, so they can, have influence on the same variables in your code, on the same classes in your code. This can maximize the CPU utilization, I hope I got that word right, and also can enhance your performance, because obviously it's like, three workers are doing a task and one worker is doing a task. Four workers are much quicker, except these are tasks like cooking, for example. I'm much slower when people help me at cooking, because when I'm cooking, no one is allowed to help me. I cook for myself and others can taste my food. I like to share my food, but cooking in the kitchen I will always do by myself, and I hate it when people try to help me. And yeah, like that, there are some tasks where multi-threading isn't even beneficial, but other tasks where multi-threading is essential. But this tutorial will be more of the basics: how to create multiple threads, how to run them, how to log them, and things like that. So what are we gonna do? First we import our package, which is called threading. So after importing our backend, we are creating a class. I call it, let me think of a creative name, iSocket. And yeah, this we are using inheritance again, because this class has to inherit from a class we have in our package, and that is threading point thread. Now a colon. And now what are we gonna writing in our class? So if you already had watched the inheritance video, you will probably remember some cases and some steps we have to do, because we are using inheritance. First of all, we have to create our constructor, which is of course definition. And now in it, sometimes I make a really stupid mistakes by writing int, which is something completely different, but we are typing in it self. Then our thread should have an ID, and a name. And if we are remembering inheritance, we first have to create an instance like this: threading point thread point init. Don't forget the self in it, I mean inside the brackets. And now, like a usual constructor, we are writing self point id equals id and self point name equals name. Now important, and like the, you can't call it essential, because you have to name it essential. Another word, it's hard to pronounce when you're German. Because we now are creating our run function, and you may be totally surprised and shocked when I'm telling you this one function. In this one function we are writing what will happen if we are running our thread. Obviously you wouldn't accept that. Now let's create our run method first. We are writing something which should be printed, like I'm a cute little robot with called self point name. Of course, we are formatting it. On my head, the number self point ID is written, and now we have a global variable which is called global var equals 0. And of course, global variables are always written in uppercase. And now, while globvar doesn't equal 1000, globvar plus 1, to write globe. Okay, back. Now I got the mistake. We have to. I forgot that if we want to get access to a global variable outside a function, we type global var. And now, yeah, there's no red line under our globvar. Just remove unimportant, parentheses, and yes. Now let's start our threads. So again, to show us our state of the global variable, we print globvar. And yes, first we print self point ID, then increase it to, and now globvar. Okay, now let's get to business. And first we are creating our threads with Harold and some hamster equals iSocket zero and hamster and now let's call it no, I don't know how to write Cthulhu, so let's call him Ollie equals iSocket has the ID of 1 and is called human. So now we created our two threads, and let's run them. So we are typing to run them Harold hamster point, and now you won't accept it, start, not one. And Ollie will also run, but start. Why we are using start is simple because start is a function which is in the threading point thread class, and we kind of we have overwritten the function 1, and now I didn't want that. After the function 1 is in the function start. So yes, if we are now clicking 1, I hope it worked. Now the two threads are working. You see? And I don't know what amount. Oh, it's large. It's, I mean, 10 billion or 10 million. So this will need some time. So let's just stop the program. But as you could see, the threads are working. And as you see, one and sometimes our second one increased our amount. Yes, they kind of work together. So what we are asking ourselves, does it really is faster if we are using one thread or if we are using two threads? For that we are importing our time. So now let's print time point time 2 times when the one started and when the one is finished. Let's decrease our global variable to 100,000 or no 1 million. And let's uncomment this one because I don't think this is important. And let's see if we run it now. Oh no, I have to use one indentation. And I guess this is too quick. Let's okay, if we increase one more. Now it's taking much more time because we are back to our millions. So let's decrease it by 1. And let's type in time points. Oh, I guess we can do it like this. E equals time point time. And time point time minus E. Yes, now that's the time which was needed. And again, if we increase it by 0, now let's wait a little bit. Maybe I skip this part if it's too long. Otherwise, I can tell you a little story about out of my youth. But no, it's too quick. 11 seconds. Now let's just use one string. One string, not one thread. Let's see how long he takes now. He is quicker. Why is he quicker? It's simple because this is like the cooking example I showed you. The cook is some tasks are easier to solve if you have only one cook. Some tasks need more workers, so it's depending on the task. For example, if you have multiple threads which have to add a connection, there's much waiting time and it's much quicker with multi-threading. Or if we are connecting to 10 different URLs where you want to get some input at the same time, you can use multi-threading, but an example like this, it's slower. Can try it again. Now what also could be influential to the fact that it takes longer is the fact that it's one global variable and both are working at the same global variable. If we are adding glob and he will increase glob, and while glob doesn't equal this large amount, and the default for glob is nothing, we type global glob, which doesn't work because I think we don't even need that, because the function itself doesn't have access to the global variable. We are just typing it. So glob No, global var. And global var2. Okay, yes, of course, because start and one is not the same function. So let's add another variable in our constructor, like glob, and self point glob equals glob. And yes, now if we run, self point glob will be increased. And now we don't need an input at start, but here we need one, which is global var and global var1. Now let's start. And yes, I wonder how long it will take. So the first one took 22 seconds, the second one 23 seconds. Now this method is already efficient if when we are only using one thread, and it will need more than half of the amount which it was before. So if it is under 11, then we should use also only one thread by this task. We should like this. But if there would be like 14 or 15 seconds, it's a task where you can say you have only one thread. But in that case, you also shouldn't use multithreading. But of course, there aren't only tasks where the threads are calculating constantly. Sometimes a thread has to wait, and another thread has, for example, to run a user interface. Another thread has to calculate something in the program when certain requirements are met. So there are multiple cases where you can use threads, but not in this one. But that's important to know as well, that using threads doesn't always make your program quicker or your code quicker. So thank you very much for watching my video. I hope you liked it. Have a nice evening, day, dinner time, whatever time it is. I can make an advanced video of multithreading as well, but this shall do it for the basic video of multithreading. I hope you could enjoy it. See you on the next video. Bye bye.